Hello, children. Today we are going to discuss about science, and the chapter is materials, metals, and non-metals. In this chapter, we will discuss about metals and non-metals and what are the characteristic properties of metals and non-metals. In this chapter, we will discuss about the physical and chemical properties of metals and non-metals. So, let's start. You are familiar with a number of materials like iron, aluminium, copper, etc. Can you name these materials? Yes, we can. These all materials are metals. Metals can be distinguished from non-metals on the basis of their physical and chemical properties. So, now we will discuss about the physical properties of metals and non-metals. We know that the shape of iron nail and the aluminium wire changed on beating. If they were beaten hard, these could be changed into a very thin sheet. We all are familiar with silver foil used for decorating sweets, as well as aluminium foil, which is used for wrapping food materials. So, the property of metals by which they can be beaten into a very thin sheet is called malleability. And this is the characteristic property of metals. If we will notice some other materials like coal and pencil lead, then these materials will not show this type of property. So metals are malleable and non-metals are non-malleable. Now we will perform an activity. Take a small iron nail, a coal piece and a piece of thick aluminium wire and a piece of pencil lead. Beat the iron nail with a hammer and try to hit hard. Hit hard also aluminium wire. Then repeat same process with coal piece and pencil lead. What we will observe? We will see that the shape of iron nail and the aluminium wire changed on beating. If they were beaten hard, this could be changed into a very thin sheet. And we all are familiar with silver foil and aluminium foil. Silver foil is used for wrapping materials, decorating sweets, as well as this aluminium foil is used for wrapping food materials. So this is the property of the metal by which they can be beaten into a very thin sheet, and this property is called malleability. This type of property other materials like coal and pencil lead will not show. So, metals are malleable and non-metals are non-malleable. Now, we will discuss the next property, that is conductivity. Can you hold a hot metallic pan which is without a plastic and a wooden handle and not get hurt? Perhaps not. Why? Try to list some other experiences in which wooden and plastic handle protects you from being hurt while handling hot things. On the basis of these experiences, what can we say about the conduction of the heat by wood and the plastics? We must have seen the electrician using his screwdriver. What kind of handle does it have? So, what are conductors? Conductors are the substances which allow heat and current to pass through it. Metals are the conductors, whereas plastic and wood, these are the insulators. What are insulators? Insulators are the substances which do not allow heat and electricity to pass through it. So, plastic and wood, these both are the insulators, and metals are the conductors of heat and electricity. That's why these electricians using this screwdriver, which is made up of a plastic backside, and the handle of the screwdriver is made up of plastic. Why? Because this plastic is a insulator. Now we will perform a next activity. You know how to make an electric circuit to test whether electricity can pass through an object or not. You might have performed the activity with various objects. Now repeat the activity with some other materials and observe the group which are good conductors and which are poor conductors. In this, we will take iron nail as well as we will take a plastic. If we will place the iron nail between the wire, that time bulb will glow. Why? because iron is a metal and metals are the good conductors of electricity. And if we will place plastic, that time bulb will not glow. Why? Because plastic is a poor conductor of electricity, as well as we can speak plastic is a insulator. We observe that iron rod, nail and copper wire are good conductors, while rolled sulfur piece, if we will take sulfur piece, we will take coal, then we will get the conclusion then these things sulfur and coal are the poor conductors or insulators. Through this we can come to know that which metals are a poor conductor and which are good conductors. Now we will discuss about the next property, that is ductility. Where do you find the use of aluminium and copper wire? Have you seen wire of coal? Definitely not. Why? Because aluminium and copper, these both are the metals and metals are the good conductors. Whereas coal is a non-metal. So the property of the metal by which it can be drawn into a very thin wire, it is called ductility. Metals are ductile, whereas non-metals are non-ductile. So we can convert metal into a very thin wire, and this property of metal is known as ductility. Next property is sonorousness. The things made of metal produce a very huge sound, a ringing sound when struck hard. Since metals produce a ringing sound, they are said to be sonorous. Have you seen wooden bell in temple? No, because this wood will not produce sound. That's why metals are sonorous as well as non-metals are non-sonorous. Now, what observation we will get after all these activities? After performing the above activities, we can say that some materials are hard, lustrous. Lustrous means shiny, malleable, ductile, sonorous, and good conductors of heat and electricity. The materials which are generally possess these properties are called metals. The example of metals are iron, copper, aluminium, and calcium, magnesium. These all are metals. On the other hand, materials like coal and sulfur are not soft and dull in appearance. They break down into powdery mass on trapping with hammer. They are not sonorous, and these are a poor conductors of heat and electricity. So these materials are non-metal. So non-metals are poor conductors as well as non-metals are non-lustrous, non-malleable, and non-metals will not produce any sound. Whereas metals are lustrous, malleable, ductile, sonorous, and good conductors of heat and electricity. Now we will discuss the chemical properties of metals and non-metals. First, we will discuss what happens when metal reacts with oxygen. When metal reacts with oxygen, that time metal oxide will form. We all are familiar with the phenomena of rusting of iron, and you had learned that both these processes possess a formation of oxides. Now, we will perform an activity. Let us check the nature of the rust formed as a result of the reaction between iron, oxygen, and water. What is rust? When iron reacts with oxygen and water, that time a brown color layer will form on the upper side of iron. This is called as rust. So, when iron reacts with oxygen and water, that time rust will form. Now, we will check the nature of this rust with the help of litmus paper. Collect the spoonful of rust and dissolve it in a very little amount of water. You will find that the rust remains suspended in water. Now shake the suspension well. Test the solution with red and blue litmus paper. What do we observe? Is this solution acidic or basic? So, Our observation is we must have observed that the red litmus turns blue. So oxides of magnesium, oxides of iron, these all are basic in nature. So in general we can speak that metallic oxides are basic in nature. Now we will perform one more activity. Take a small amount of powdered sulfur in a deflagrating spoon and heat it. If deflagrating spoon is not available, then you can take a metallic cap of any bottle and wrap a metallic wire around it. Now, as soon as sulfur starts burning, introduce the spoon into a glass jar and glass tumbler. Cover the tumbler with a lid to ensure that the gas produced does not escape. Remove the spoon after some time and add a small quantity of water into the tumbler and quickly replace the lid. Shake the tumbler well. Now we will check the solution whether it is acidic or basic with the help of litmus paper. Now, if we will check the solution with the help of litmus paper, so for this, first we will name the product which is formed in the reaction of sulfur and oxygen, that is sulfur dioxide gas. When sulfur dioxide is dissolved in water, that time sulfurous acid will form. What will be the reaction? Sulfur dioxide, that is SO2, and water, that is H2O. When reacts with each other, that time sulfurous acid, that is H2SO3, will form. The sulfurous acid turns blue litmus paper to red. Why? Because this is acid. And acid turns blue litmus paper to red. So generally oxides of non-metal are acidic in nature. In this case, sulfur and oxygen both are non-metals. Now we will discuss reactions with water. What happens when metals and non-metals reacts with water? Sodium is a metal and sodium is a very reactive metal. It reacts vigorously with oxygen and water, and a lot of heat is generated in this reaction. It is therefore stored in a kerosene. Now take a 250 ml beaker, tumbler, and fill half of it with water. Now carefully cut the small piece of sodium metal. Dry it using filter paper and wrap it in a small piece of cotton. Put a sodium piece wrapped in cotton into the beaker and observe carefully. What we will observe? We observe that the sodium reacts vigorously with water. Some other materials do not do so. For example, iron reacts with water very slowly, and generally non-metals do not react with water, though they may be very reactive in air. Such non-metals are stored in water. For example, phosphorus. Phosphorus is a very reactive non-metal. It catches fire if exposed to air. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. Now we will discuss what happens when metal reacts with acid. For this, we will perform an activity. Take a sample of metals and non-metals in separate test tubes and label them as A, B, C, D, E and F. With the help of dropper, add 5 ml of dilute hydrochloric acid to each test tube one by one. Observe the reaction carefully. If no reaction occurs in the cold solution, then warm the test tube very gently. Bring a burning matchstick near the mouth of each test tube. Repeat same activity using dilute sulfuric acid instead of dilute hydrochloric acid. Now record your observations. What observation we will get? Is there difference in the way metals and non-metals react with acid? What could be the pop sound? in some cases be due to when a burning matchstick is brought near the mouth of these test tubes. So, when acid reacts with metal, that time salt and hydrogen gas will form, and this hydrogen gas will produce pop sound when we will burn this gas. What observation is there? We must have found that non-metals generally do not react with acid, but metal react with acid and produce a hydrogen gas that burns with pop sound. We must have noticed that copper does not react with dilute hydrochloric acid even on heating, but it reacts with sulfuric acid. So some metals will react with sulfuric acid. Now prepare a fresh solution of sodium hydroxide in a test tube and dissolve 3-4 pellets of it in 5 ml of water. Drop a piece of aluminum foil into it. Bring a burning matchstick near the mouth of test tube and observe carefully. What observation we will get? In this case, we will see that when sodium hydroxide reacts with aluminum foil, that time salt and hydrogen gas will form. Some other examples, like if will take copper sulfate and zinc granules, that time when copper sulfate reacts with zinc granule, this time zinc sulfate and copper will form. When copper sulfate reacts with iron nail, that time iron sulfate and copper will form. Zinc sulfate will not react with copper and iron sulfate will not react with copper. Same, zinc sulfate will not react with iron nails. But in all these reactions, hydrogen gas will form. What observation we will get? As before, the pop sound indicates the presence of hydrogen gas. Metal reacts with sodium hydroxide to produce hydrogen gas, and reactions of non-metal with base are very complex. Some non-metals will not react with bases. This time we will discuss the displacement reactions. For this, we will perform an activity. What are displacement reactions? In these reactions, metals will displace to other metals. In this case, take a 500 ml beakers and label them A, B, C, D and E. Take about 50 ml of water in each beaker. Dissolve in each beaker a teaspoonful of each substances. Now, what observation we will get? We have read that one metal displaces another metal from its compound in aqueous solution. In the beaker A, zinc replaces copper and copper sulfate will turn into zinc sulfate. That's why the blue color of copper sulfate disappears and a powdery red mass of copper is deposited at the bottom of the beaker. This reaction can be represented as when copper sulfate reacts with zinc, that time zinc sulfate and copper will form. Now, what observation we will get? There could have been displacement of zinc by copper in a beaker C and by iron in beaker E. Similarly, iron could be displaced by copper in beaker D. Since we do not see any change in the beaker C, we can infer that copper is not able to replace zinc from zinc sulfate. But why? When zinc can replace copper in beaker A, why cannot copper replaces zinc in beaker C? Remember that these some metals are more reactive than others. So only more reactive metals will displaces the less reactive metals. As the rule here that zinc is a more reactive than copper and iron. A more reactive metals can replaces the less reactive metals, but a less reactive metal cannot replace the more reactive metal. Now we can understood that why there is a no displacement reaction in beaker D and beaker E. Now we will discuss what are the uses of metals and non-metals. We should be able to guess why metals are used to making machinery, automobiles, airplanes, trains, satellites, industrial gadgets, cooking utensils, water boilers, etc. We all are familiar with the uses of some non-metals also. Metals are malleable, metals are ductile, as well as metals are the good conductor of heat and electricity, and these metals are strong. That's why for making machinery, automobiles, airplanes, trains, and satellite and industrial gadget, this metal is used. Some other uses of metal and non-metals. Non-metal essential in our life, which are living beings inhale during breathing, that is oxygen. Non-metal used in fertilizers to enhance the growth of plant, that is NPK, nitrogen, phosphorus, and potassium. Non-metal used in water purification process, that is chlorine. Non-metal is used in a purple colored solution which is applied on wounds as an antiseptic. Non-metals used in cracker, that is sulfur. Some other uses of non-metal are we can use these non-metals in our daily life. So metals and non-metals both are necessary. Now we will discuss about the elements. You have learned that the chemical reaction new substance will form. These substances are different from those which underwent the reaction. Now, if a substance cannot be broken down further by chemical reactions by cooling, heating, or by electrolysis, so it is called element. We can't break element. Sulfur is an element, so same as in iron. Carbon too. Sulfur, iron, carbon both all are elements. The smallest unit of an element is atom. A sample of element contains only one kind of atoms. The atoms of an element remains unaffected by physical change of the elements. For example, an atom of a liquid sulfur would be exactly the same as the atom of the solid or vapor sulfur. Although we have an infinite infinite variety of substances in the universe, the number of elements forming these substances is limited. There is no more than 92 naturally occurring elements. An important classification of element in its term of metals and non-metals. Most of elements are metal and less than 20 are non-metals. Some are metalloids also, and metalloids which possess characters of both metals and non-metal. So, dear children, this is the description of the chapter 4, that is materials, metal and non-metal. Thank you.